Share the screen, so the screen is recorded too. Um, again, the only reason that I'm actually creating a meeting and ask you to join, added you to this one, is to make sure you have access to it. When you click on it after the class is over, you can actually see the recording. There is no guarantee, again, that the recording is going to be there. This is an in-person class. Recordings are not my responsibility, but it's what I've been doing with for 2 decades. I try to record everything and put it on YouTube, and now we have this, so it's got to be on Teams too. Again, don't rely on it, but if it's there, it's a bonus thing for review. That's that. As usual, we are going to create a new project, and it's going to be inside the repository. I have seen many of you have already done Workshop 0 and send me invitations for GitHub, which is very fine. Thank you. My request is double check your README file and make sure it is formatted properly. One of the things that I ask the students to do, and you'll see that you're going to need that for the rest of your career in programming, is to be exact. Programming is an exact science. It's not something that you do and it's kind of okay. When I ask something to be represented in 4 lines, it has to be 4 lines. It cannot be 3 lines. If I ask you to the extent of saying, when I want I didn't ask this, but if I ask you, I want you to write your subject with a space and the number and a space and a section, it means OOP space 244 space NAA. If you leave that, don't put those spaces, it's not acceptable. It has to be exact. So please take a look at the Workshop 0 and make sure that it is exact. And as you are going to continue submitting your work with the submitter program, you'll see that your programs must be exact, which means you cannot have kind of right output. It has to be the exact output, okay? And that's what we are going to do. So if I were a student and I wanted to work on something, this is how I would have started. I start Visual Studio. I start, or Xcode if you have an Apple. Create a new project. It's going to be a C++ Windows console. Sorry for the Apple computers. This is a Windows-based subject, so I don't demonstrate on Xcode. It is only Visual C++. If you're doing Xcode, you're kind of on your own. I'll try to help, but my knowledge of Apple is the size of a small little thing, so I really don't know much about Apple. Anyways, so you click, you select an empty C++ Windows console project, and you select the repository that you created for your OOP244. And again, as I said, you live and breathe in there. If I ever go to your repository and check your repository, I should be able to see how active you are. And as I mentioned, every time you add something to your repository, make sure you keep committing your work so it shows your progress. So as I start now, I'm going to select the folder that is the repository of my work. I'm going to go to the notes because that's what I'm going to do, write notes for you guys. If you're here, please mute your microphone. Thank you. All right, and select folder, and I'm going to call it C because it's the 3rd one, C May12. So like that, we show the sequence of the sessions, and the ABC kind of keeps it in order. It sorts it, so we know it's always, we can always tell which one is first and which one is next. And then I'm going to create the console application, and that's going to bring up Visual Studio with all the good stuff that I have. You close all the tabs except Solution Explorer. You don't need anything else. Even if Solution Explorer is closed, no problem. You can always go to back view and click on Solution Explorer or Control-Alt-L. It's going to open Solution Explorer. Right-click on the source files, add new item. If it's a new one or if you have an already existing one, you can add it. A C++ one, and I'm going to call it prg.cpp. And a blank file is created. Over there, I'm going to say include iostream using namespace std, because we are going to use cin and cout, console input and console output, which are defined in namespace std, and therefore we use namespace std over here. Now I'm going to write int main, and I'm going to insert into cout OOP244NAA May12. Return 0. Compile and run the program, which is Control F5 without debugging. It runs the program. I know everything's good. Now I can actually start my work. But because I just created this, and as it's a point that I may want to come back to, what I will do, I will always open git sync open, so I can keep committing the work. So I'm just going to say in here, started May 12th session. I'm going to select all. I don't care when I select all because my git ignore is set properly, and therefore it's going to ignore all the garbage files, and only the good files that are needed will be added. And I'm going to just commit. I'm not going to push. Oh, I did actually push by mistake. Anyways, you can just commit, and push once, or you can commit and push all the time. It doesn't make any difference. So now it's ready. I'm going to put it over here. If you were on command line, then you had to do git. So you had to go to that directory and write. So let me actually do. Maybe it's better to run. I'll go to git bash. Actually, maybe I can actually start git bash right at the directory. So let me just see. I'm going to open the folder. And I thought I can do it, but I think maybe I can't. Okay, I recall that we had a git bash here kind of thing, that you can actually open a bash right in a directory, so you don't have to cd to it. So copy. Now I'm going to start git bash, which essentially it's like a Linux prompt, okay? And now I'm going to say cd. I think I can go ct/d/ if I recall correctly. It's the other way. Darn it. So will it work like this? No, it can't. So now one more time. Now I have to change everything to slash. Anyways, so you can go over there and you can actually say git commit -m. Then I'm going to say started May session May 12 session. You commit like this, and then you can say git push to push it to whatever repository that you're in. That's for Apple people. If you are using Apple, you open a terminal client and you do that. It is in Workshop 0, and you know what it is. Anyways, I'm not going to do this every time. It's just the first few times I do this just to kind of remind you of how things are done. Okay, so a quick recap of what we have done last time. We talked about all the things that we are supposed to do in class, and rules and regulations and policies and things like that. And I think we started with object-oriented programming and explaining what object-oriented programming was. Remember? You good with that? Anybody remembers that? No? Object-oriented, encapsulation, polymorphism. Did we talk about that in class? We did talk, right? So we said that encapsulation is essentially putting the data and behavior together. This is something that we did not have in C. In C language, we could create structures, create records, but the records that we had was kind of dead records that they couldn't do anything. I had a student, I had all the information about the student, but I didn't have everything about what the student itself couldn't do anything. But we said that in C++, we have the very first important feature of object orientation, that is putting the data and behavior together. Why did we do that? Because we want to organize our code as if, organize our work the way our thinking works, the way objects work in the real world. And we said every single object that we have, all cell phones are cell phones. They all make calls, but they are not identical things. All computers are computers. Their job is to do processing or whatever they are doing. There are different ones, but we all know how they work. Because they're computers, they have the same features, they have the same properties, they all have keyboards, they all have screens. Some screens are touch, the other ones are not. Some use mouse, some use touchpads, but they are essentially, when I tell a computer, everybody can picture something, okay? All the common things. And the computers do what they do. Like if you have a vehicle, the vehicle's job is to transfer people from A to B. Its job is to move people, and it has action in it. Because of that, we need to put data and behavior together to simulate what we have in real world. Every single pack of property that we have, it's capable of doing things. That's encapsulation, putting the data and behavior together. Then we said because of that data and behavior together, a side effect comes through, which means it actually hides the data from others. Did I give you the example for the Tim Hortons lineup? No? Okay. So what encapsulation does is it actually puts the data and behavior together, which means I can tell to a list to print itself and list prints itself. We said if we have a list, and list is a menu of a restaurant, if I say print, a menu of a restaurant is going to get printed. If the list is a transcript for a student, if I say print, the student's list is going to get printed. So things like that happens. But the good thing about this encapsulation is that it actually hides the information from outside. You only see the public things that the features that object has. And this example, I think I gave it to you in OOP244NAA. And I said, do you know that I can salsa? I can dance salsa. Do you care? No. I'm your teacher. That's hidden from you. You don't know it. Unless I am actually teaching dancing to you. I can't. I'm teaching C++, so that's what you see from me. The rest is hidden. And the Tim Hortons lineup was that if I go with my student to have coffee at Tim Hortons, if we are standing in line, he gets his coffee, then I get my coffee, and I don't have my wallet with me. If I ask my student, can I borrow $1.50 to get coffee? I forgot to bring my wallet. Because it's my student and I'm a prof, right? He wants to be good to me. It probably gives me the $1.50, right? And I'll get the coffee and life is beautiful and everything's good, and I'm going to give the $1.50 back later on. And any of you probably in the lineup, if you have the $1.50, I think you would give it to your prof, okay? And even you don't want it back, right? Probably. But now let's do the picture like this. I am standing in lineup, and he's standing in lineup. He gets the thing. I don't have my wallet with me. I say, oops, I want $1.50. He's my student. He's going to give me the $1.50 anyway. So I put my hand in his pocket and look for $1.50. Then what's going to happen? Probably a slap in the face and a robbery charge or something, right? What is the difference? They both work. Yeah, but what's the difference? He would have given it to me anyway. See, it's like, it's obvious to everybody that it doesn't work that way. You have to ask for permission, right? That's what we don't have in C language. In C language, you create a structure. Structure has 5 fields. You can simply put the name of the structure, dot, and access anything in it. It's all open. But in C++, it's not like that. When you create a structure, you create actions, and you actually ask the structure to give you $1.50. You cannot put a dot beside it and just change the value of the money in the pocket of the student. You can't do that. You have to ask, you have to call the borrow action to borrow money from the student. And that privacy is a side effect of encapsulation. Okay? We're going to show you how we implement it. This is all review of the last session. There's nothing new down to this point. The next one was polymorphism, as I mentioned right now. Polymorphism, poly means many, morph means shape, many shapes. Essentially, it means that you can have different types of functions doing the same thing. As I mentioned, you tell to a menu of a restaurant that is a list to print itself. A menu is going to get printed. If you tell to the transcript list to print, a transcript is printed. Okay? And if I ask a butterfly to fly, butterfly will fly. If I ask an airplane or instruct an airplane to fly, an airplane is going to fly. Both actions are flying. But it's happening in a different way. So doing the same thing in different ways, that's called polymorphism. And another thing that I want to tell you, okay? If I see one person distracted by the screen in front of you, everybody loses their screen. And this is your only warning, okay? When I'm talking, if I see you are looking at a screen and your face shows that you are not listening to me, you are looking at something else, everybody will lose their screens. I'm not going to say who did it. And I'm just going to say, screens closed. Then you go find out who did that. You don't need to close it now. And as I think I mentioned, did I talk about the processors we have in our brains? I didn't talk about it in this class. We have only one language processor, one processor in our brain. We don't have 8 cores in here. Human beings have only 1 core. Okay? When you look at your screen, even when you are listening to me and typing, because the action is not an analog thing, it was just distraction. It's proven by research. I'm not joking. So you type and you see what I'm saying, that's when you lost me. Then you're going to ask me a question later on that I just talked about because you missed it. Right? Right. Okay? So, and that's a fact. If you want to learn, if you want to remember what I'm saying, you should take notes because that's an analog thing. When you're listening to me, your brain translates that first from English to your processor thingy, so you translate it to thing, your brain understands, then passes it to your muscles, muscles translate that to movement, and then you write. Therefore, it gets committed to your long-term memory. Okay? Because I'm writing every single code that we have, absolutely no need, there's no need for your computers. But if it makes you happy, keep it open. I'm a liberal person, okay? So you can do it, but if you're distracted, I'm not going to pick a fight with the person. I just do, everybody close, just be aware. So every now and then you're going to hear me saying, computer's closed, okay? So I apologize then. Anyways, so polymorphism. That was doing the same thing in many different ways. You ask me to teach, and C++ is going to come out. Then you take an EAC, EAC 150, that's English, right? Did I say it right? Is that the code for college English? It was when you go to an English class, you ask the prof to teach, English grammar is going to come out because that's what, so they are both teaching, each one does it in a different way. And therefore, teaching becomes a polymorphic thing. That's second aspect of object orientation. So we have to learn how to do that, okay? The third one that we need to know is reusing design, okay? When you have something that works and you know how it works, you don't need to reinvent everything. You simply get that design and add something more to it. We have a vehicle. Out of a vehicle, you can create a car. Out of a car, you can create a BMW. When BMW wants to make the car, it doesn't go from the beginning and say, how many wheels I have to put for the car? It's not going to happen that way. Everybody knows what a car is. The definition is everything. It is the same. They have the wheels, they have the steering wheel, they have the acceleration, they have the brake to stop. All the standard things come with the design, and after that, it's added with something new. If I told you, again, we talked about this in class, if you are living in a village that they only have cars and bicycles, if you want to explain to them what a motorcycle is, all you need to tell them is, motorcycle is a bicycle with an engine. And then everybody would understand what a motorcycle is. You don't have to go through it. That we call inheritance. Inheritance has nothing to do with what we do in biology. In biology, I inherit stuff from my father. Okay? That's not inheritance. Inheritance is me being a mammal. That's inheritance. With respect to my mother and my father, my mother had a function called birth that returned a human being. That function was called, and I was born. I have no inheritance with actually we are from same class. My mother is a female human, my father is a male human, and the outcome of the marriage and birth has an outcome, and that's me. That's the object-oriented design of it. But if I tell you I am a human, then that becomes inheritance. If I told you human, close your eyes, everybody knows what a human is. Then I have to be more specific to, I have to keep inheriting to something new, nationality, language, whatever it is, race, keep going forward until it becomes a definitive thing that you can actually see what it is. We good with that? Again, vehicle, car, BMW, it's still not finished. I have to give you the model. And when I give you the model and everything, now you can picture it. And then you have to go see the attributes, see if it's blue, red, white, whatever it is. Okay? We good? So now our job is to go through different aspects of object orientation, because supposedly you know how to do C programming. So we're going to add one feature to C. And we mentioned we call it C++ because one feature is added to C, and that's object orientation. So I'm going to tell you how to implement your code so it has those three features within. Are we okay? Questions? Suggestions? Objections? All right. So was that a question? No, you were just searching? Okay. I have a very serious class this semester. Everybody's extremely serious. I hope it's good. All right. First thing that we need to understand are types that we have in C language. So in C, and when I say C, I mean C++. The types that we have in C++ are exactly like C. So we have our characters. Okay, what is a character? You have the microphone. You remember the game, right? Whoever has the microphone answers the question, or doesn't want to talk, he says pass, goes to the next person, pass, goes to the next person, and it goes like that. Or you will answer and pass it to the next person. Okay, what is a char in C language? Do you remember?
it's just a symbol like a
It,
of the ASCII code.
it holds, okay, that's actually a big important point. It's a character is a variable that holds an ASCII code, which means what is the type? By the way, we have two types in C language and two types only. We don't have any other type. We have integrals and we have real numbers. That's a little too mathematical. Let's put it in things. We have integers, we have floating points. Integrals, real numbers. That's it. There are no other types in C language at all. Having said that, which one character falls into? Which one? You're going to answer soon. Which one character falls into? Integer or real or floating point?
Pass.
You guys have to work.
Integer?
Integer. Thank you. May I ask your name?
Marzia.
Okay, thank you. So integers. A character is essentially an integer. Why is it an integer? Because it holds the ASCII code of something. So when you are actually writing a code and you're saying, you're writing character CH and you put over there A, you're saying C out CH. What does get printed? An A, right? That's perfectly correct. But if I did this, and I put some space over here, actually, let the space be. What happens if I do this? Now what's going to get printed?
Only 6.
Huh?
Only 6.
It will be 6 in spaces.
Is anybody online in this class? Hello? Hello? Jose, you are not supposed to be online. This is not an online class. You should be in class. Okay, but now it's fine. Thank you, but please next time be in class. This is not an online class. Okay? Okay. Then if we don't do this, then I have to stop recording it on Microsoft Teams. Okay? Please join the class. You cannot be online. Okay. But thank you very much. So what was your answer? Now that you said it, what is your answer? Yeah. So it's gonna print the character. The character is 66, and 66 is B. That's the ASCII code of B. So if you actually use B, so if I say over here ASCII chart, and bring one of them up, whatever it is, doesn't make any difference. These are the ASCII codes. So as I was mentioning, 60 decimal is here. 66 was B. You see that? 67, 68. These are the ASCII code of the numbers. So there is no character in C. It's just a number. You are just asking the C language to print this integer, print the shape of this ASCII code, and the A is printed. And that's the only thing. You have to remember that it's extremely important. Because of that fact, now I can actually do this. Remember how we did casting in C language? We put the type and we change the type temporarily. So we actually can write over here int, and I write over here ch. So if I do this, it actually shows B and it shows 66. Right? So I can actually do something like this. I can actually write for ch set to A and CH less than or equal to Z, and CH plus plus and that shows all the characters and their ASCII code. Are we okay with this? You okay with this? All right. So we are going somewhere. And that's the smallest integer we have. One size bigger, and how many bits in a character?
It's 4.
Bit, B-I-T. Oh, okay. So we don't. Did you guys take any course about characters and stuff, like bits and stuff? Not at all. We didn't. Yep. So one byte. How many bits in one byte? No, 8. Yeah, 8. 8. Okay. Oh, we have to. All right. So. I think I had a marker with me somewhere. Those markers probably don't write. That's what they put it over there. I had a marker, actually. I brought a marker over here. Let me see if I can find it. This is not part of our OOP244, but hey, I have to do something. Oh. Okay, so this is something that you need to know, so it's better to, I don't mind if we are a little behind, but I rather mention these. So how far I can go here, and how far I can go here. Okay, I just want to know where I can write, okay? So if I have one LED light or a light somewhere, okay, and I'm serving tea or coffee. If the light is on, it means there is coffee. If the light is off, it means there is no coffee. So how many different things I can show with one light bulbs? 2, right? Now if I have 2 light bulbs, how many different things I can show?
3.
I can actually show 4 different things. I can say if they're both on, I have coffee and with sugar. If the first one is on, the second one is off, I have coffee without sugar. If I have first one off and second one, oh, sorry. Second one off, I don't know how to show it. It's going to be, so this is what it is. Let me show you. So I can have first one off and second one off, both off, right? I can have first one on and second one off. I can have this one on and first one off, second one, and both, right? So I can show 4 different things. What if I have 3? How many different things I can show? 8, thank you. 2 to power 3, actually. Okay? So if I have 3 of them, this is what I'm going to have. Right? What if I have 4? How many I can show?
16.
There we go. I can have, we are doing programming, right? So we start from 0. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, correct? That's half a byte. If I have 5 of them, I can show 32, right? If I have 6, that's 64. 7, 128, and 8, 256 different things I can show. And that's your ASCII code. So essentially, when you were talking about ASCII code, because they wanted to show contents of a byte, 8 came out very natural. And when you divide it by 2, and the 10 to 15 over here, they said, we're not going to use that. Probably this is the last time you see me write something on the board, but hey. So they said, we're not going to do this. Instead, we're going to say A, B, C, D, E, and F, right? So now you see people do 3F, and they say that's a byte. How do they say it's the byte? 3 is 0, 0, 1, 1. F is 1, 2, 3, 4. So 3F is actually the value of the byte. And that's how they came up with an ASCII. Because they said, how many bits I can put to show the alphabet? They said, 3 is not enough. 4 is not enough. It's only 16. When I go 5, it's 32. So 5 bits okay, because I have only how many letters in alphabet? 26. So 26. So I can do 5. But what if I want to do lowercase and uppercase? So let's make it 6. What if I want to have curly brackets and dots and punctuation? So they made it 7. But 7 wasn't symmetrical. You cannot put 2 digits like that and show 7. So they made it 8. Actually, it used to be 7 long time ago in a galaxy far, far away. But then they changed it to 8. And that's why when you are FTPing now, you have to select if it's text or it's binary. And that's how old FTP is. So that's why I'm saying if you're still using FTP, come on, right? Use Git. Anyways, so that's it. So that's what things. So that's why a character has 8 bits. Okay? So that's why the character has 8 bits. It goes from 0 to 255 if you want to use it as an integer. It's going to unsigned integer, 0 to 255. And if you want to go negative, then it becomes from minus 228 to positive 127. How many fingers? How many fingers? 10. Okay, so if I have 10 fingers, I'll go from 0, here. Find a seat over here, somewhere around here. You can go over there. This is especially with your name with it. Yeah, there you go. The reason is that the screen is. So if I have 10, right? 10. It goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? Now if I want to show negative and positive, you should decide which one is 0, this one or this one. Let's say 0 is this one. If 0 is this one, it becomes minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, right? Therefore, that's why always negative numbers are 1 more than positive numbers. Okay? It's the exact same thing with short integers. So short integer is 2 bytes, which is 2 to power what? 16. And that becomes 0 to 32,000 something, or from minus 16 to positive. And then the next one is 4. I don't want to tell you. So that's, and then the next one is 8. So these are the types that we have. Now the smallest size, so which brings us to the question that you're going to get in your concept thingy. How many different types of, how many different categories of types we have? 2. Integers and reals. What is the smallest integer? It's a character. It disguises itself as a character. It's not a character. We don't have characters in C language. It's an integer. An integer that has only 8 bits. Then after that, we have short. Short has 2 bytes. After that, we have int. Int has 4 bytes. After that, we have long. Long and int, they both have 4 bytes. That's because in different operating systems, the size of integer is different. So put it that way. Then we have long, long. Long, long becomes 8 bytes. Then we have long, long, long. No, I'm joking. Long, long is the last one. Okay, long, long is 8 bytes. And that's that. So that's the things that we have. That's as big as it gets. 8 bytes is what? 64 bits. 2 to the power 64. That's the maximum thing that you get. And divided by 2, negative and positive. So anything that is unsigned, it's 0 to a big number. When you make it signed, it's negative to positive, half a value. Are we good with that? Are we okay? All right. Now, real numbers are different. Real numbers, they use scientific notation to keep the values. They say we're going to have an integer part, and we're going to have, so we have 2 different parts. And so essentially, one holds the number, and the other one holds to the power of 10. Okay? So that's how they actually hold the real numbers. And I don't want to go through the details of math, but because of that fact that they're holding it like this to be able to hold some value, it's not precise. You can never have a real number with a precise number. It always has something. So you always lose pennies somewhere. Okay? You have to be extremely careful. When you create a floating point number, and the smallest real number, floating point number is float. And then afterward, they call it double. It's not because it's double size. It's actually much bigger than a float. It says double because the precision is double. It's twice as precise. And then we have long double. Long double is very precise, but it's still not 100%. The only values that you can actually measure with equality, and you're 100% sure they are good, they are integers. If you have 2 integers, you put values, you can actually check for equality. And 100% they're going to be okay. But if you have 2 floating point numbers, one A, the other one B, and you do mathematical calculation, one of them becomes 4 and the other one becomes 4, if you compare the 2, there is no guarantee they are both 4. Even if mathematically there must be both 4. One of them might be 3.9999999999999. The other one be 4.00000000001. Again, floating point numbers are never precise. You good with that? So we know what the types are. Now, this was C actually, has nothing to do with C++. In C++, they saw people are freaked out by the fact that we check the truth and falsehood with 0 and non-zero. What is false in C language? 0. What is true in C language? Anything that is not 0, not 1. So 0.25 is true if you check it for truth or falsehood. So truth, or we have only one false value, and that's 0. Anything other than that is true. Do we understand this? All right. And it freaked people out, because conditions like that was a little difficult to understand. So what they said we're going to actually create, how do I take this thing off? There we go. So they said, how do we actually make it easier for people to be able to hold conditions, the state of a condition? What is that? They said, let's actually add a type. We call it bool, for Boolean. It comes from Boolean algebra, true or false, the only values that he has. So an integer in Boolean algebra can only get 2 values, 0 and 1, and that's it. That's why they call it Boolean. So if you create a Boolean variable, the Boolean is actually 1 character. But anything non-zero you put in it, it will set it to 1. It doesn't care what you have. So if you have a Boolean value, and you put 55 in it, and you print it, 1 gets printed. Boolean is an integer that only accepts 0 and 1. But all the old stuff works too. It's better to return Boolean, so you are actually telling people, hey, this is returning a condition. Okay? Truth or falsehood. But again, you can put any integer value inside the Boolean. If it's not 0, it sets it to true. So, as a result, Seriously? Very low. Okay, so if you're assessing a condition, if you create a condition, A greater than B, C being equal to D, K not equal to J, these values always return either 0 or 1. It cannot be anything other than that. So the result of a condition, it's always 0 or 1. But if you assess a value to see if it's true or false, that's 0 and non-zero. Remember that. So you say if condition. If the condition is false, it's 0, it's false. If it's not false, if it's not 0, any value, it is considered as true. But if you assess a logical operation and it returns a true or false, it is always either 0 or 1. That brings us to this. So this is for, so again, I'm going to use it as usual. So I'm going to say over here a char.cpp. So we know what characters are. Now I'm going to go to the next one, which is Boolean. What is Boolean? Oh. Let's have this at the top. It's not a bad idea. So I can go Boolean condition. Okay? And if I say cout condition, what's going to get printed? I didn't set it to anything. What's going to get printed? 0. Again, it's a fake thing. Don't think that false means false. It's going to print false. It's not going to do that. It's an integer. It doesn't know what is false or true is. So it's going to print a 0 for you. It doesn't understand anything. And if you put over here and say now condition is true, it's going to print 1 for you. All right? I remember the time that C++ actually didn't have that. So let's say condition, I'm going to put 1, 2, 3. I remember the time that that actually was 1, 2, 3, but it's going to print it as 1. Right? Do we understand this now? Okay, simple, straightforward. And because of this fact, you need, because of this fact that conditions are actually operations. It's like any other operator that you have. We're going to talk about it when the time comes. But like you have A is equal to B plus C. Plus is an operator, right? Gets A, it gets B and C. The value goes back to A. The same thing with conditional operators. No difference. They're all exactly the same. So if I have something like integer, if I can type it, integer A being set to 10, and B being set to 20, and C being set to, C, no value. Now, if I say over here, C is set to A greater than B, what's going to get printed? Line 14. What is the output of line 14? 0. Because it's false. So don't give, remember, every operator in C language works like this. It has 2 operands, or 1 operand, gets the value, does whatever the operator does, and returns the value. It doesn't matter. If it was plus, it would be 40 or 30 over there. But if it's greater, if it's less than, then it would have been 1. Okay? So be aware of that, and when the time comes, we're going to see what it is. So these are the types in C language, C++. Whoa. And that brings us some cool coding. You can actually do some nice stuff with these type of those who've been seasoned in C programming, they can write very fast programs using features like this. Like, for example, if I have an array of billion numbers, and I want to find out how many of those are greater than 10. You have to write an if statement, right? That takes a long time. But you can actually write a program that's very quick to do so, much quicker than an if. So if I have something like integer array, and that integer array of mine, say I have 10 integers, and those 10 integers are is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I think it's 10. I will find out. Anyways, so now if I want to find out how many of these things are greater than 5, a rookie C programmer writes integer I set to 0, I less than 10, and I plus plus. I'm going to use that C thingy for it. Writes if array I is greater than 5, then it writes C++, right? And it sets the C to 0. Are we okay with this? So it actually says we have 4 of them, right? A seasoned programmer does it like this. A person who has written C programs for a while will do this. They will not write an if statement because it's much faster, right? An if statement, actually, it's a comparison, and then it's a jump. It takes a long time for a CPU. But this one, it simply says, what is the result of this condition? Either 0 or 1, right? If it's 1, 1 will be added to C. If it's 0, 0 will be added, so it counts it. So this is much faster than the other. Are we all good with this? Are we okay? If I'm going too fast, let me know. Are we good? All right. Okay. So running this, you're going to see that the outcome of the things are exactly the same. Oh, what is it? What's going on? Oh, yeah. Okay. So C is going to be bool and logical. Questions? Suggestions? Objections? 5 minutes break. I'm going to pause the recording. So, first aspect of object orientation in C++. Polymorphism, we'll start with polymorphism. Polymorphism has many different types that falls on the category of many different types. So essentially, as we are going through the semester, I'm going to tell you the polymorphic stuff that you've used even in C. Then I'm going to show you another polymorphic thing that we only have in C++. And the other two is going to go to the end of the semester. So you're going to see at the end. But when you are writing a simple operation, if you write something like this, if you have float A and B and C, or float A and B, let's put this one 10.2, and you have integer I and J, and put over here 4. If you write over here I is equal to J plus 10, and you write A is equal to B plus 1.23, aren't these two things both pluses? They are, right? They are both pluses, plus, okay? They are both additions, right? And the types of this one are 2 integers. And the type of this ones are 2 doubles. How did it work? Plus, you give it whatever you give it, it knows how to work. That's polymorphism. Okay? I know it sounds very lame, but yeah, that's really, really polymorphism. And this actually, and even if you do this, it actually works. So it gets the value of 4, adds 10.2, and we know that the outcome is going to be 14.2. Then casts that 14.2 and puts it in I, and you're going to have 14 over there, right? And if I put A is set to, and if I put over here, and if I say A is set to J plus B, then you're going to have 14.2 in here because the outcome of these two, right? So these are all polymorphic actions. That's the first one. And you had it in C, not in C++. But we get it in C++ and we have it. So that's the first polymorphic thing which is essentially casting. So anything that automatically gets casted by the language to make it work is a polymorphic feature, number one. Number two, we did not have this one in C. Automatic casting is polymorphic. Another one is this. Let's say I want to draw a line. I'll draw a line like that. I'm going to write void line, and I'm going to put over here integer length, right? Actually, now that we are doing it, let's actually do it using a module. So I'm going to create a module over here. I'm going to add new item. I'm going to call it lines.h. That's my header file. And then I'm going to have add new item lines.cpp. In here, I'm going to say, if not defined, you remember from last time, right? Seneca underline lines h. I copy that, and I put define over here. That safeguard guarantees that the header file is included only once. Then I'm going to say namespace Seneca. I create any code that I have in Seneca. This is an empty header file. Anytime you create a header file, you put these things in, then you start thinking. It should be muscle memory. Okay? Any header file, that's what you do. Now, for the CPP of that module, I have to say include, obviously, lines.h. And in lines.h, I'm going to say I'm going to say namespace Seneca. And that's my empty module. So whenever you are creating a module, that's how you start. And now we start thinking. So I want this main to start using that. So the first thing I'm going to do is over here say include lines. And I'm going to say using namespace Seneca. Now I'm ready to rock and roll. Are we okay with this? And I don't know if I'm going to use IOStream or not, but we'll see. You okay down to this point? Okay. So I want to draw a line. So what am I going to do? I'm going to say void line, and then in here I'm going to put integer length. So what do? The good thing about IDEs are like I can actually right-click over here and I say, create definition in lines.cpp. It knows that you're supposed to do that. So it actually creates it for you. Creates the body over there. It knows you have the prototype. So it creates a body. I'm going to split the window. As you see at left, I have the prototype. At right, I have the body. So what do? I'm going to say for size t. What is size t? A new type in C++. Anything that cannot be negative, use size t for it. For someone's age, it cannot be negative, right? Length of a line cannot be negative. Anything that you don't want to have it as negative value, use size t for it. It's good for your health. So that length thingy is wrong over there. I should have actually put size t, right? And size t. Okay? Now I'm going to say for size t set to 0, I set to 0, I less than len, and I plus plus. I'm going to draw, oh, see, I have C out, so in here I need IO stream. And using namespace std. If I don't put namespace std, then I have to keep doing this. Std. I have to keep doing that. I'm too lazy to do that. But over here, just to show you, I'm going to do it that way. So I'm going to say over here, C out. And I'm going to draw a line with, let's say, a dash. OK? And I'm going to go to new line. And I cannot say C out. I have to say std. And I have to say std. Because these are in namespace std. OK? And why is it showing me this? Line not found. It's right there. See, that's one of the things of IntelliSense. Let me just show it, do it like this. You see, now it remembered. So sometimes the wiggly things that the IntelliSense tells you, it's not true because just, anyway. So now if I come in here in my program, I can actually draw a line with 50 characters. Are we OK with this? Are we OK with this? Oh, wait. Sometimes you want to draw a line, not with a dash. You want to have your own character. Draw a line with pluses. Draw a line with whatever, right? If I want to do that, if it was C language, what would I do? I want to write another function that draws a line. So I would call it something like void line with char to give it a new name. You don't need that in C++. In C++, you can have the same function written with different number of arguments. So in here, I can actually write size t, len, and a character ch, or fill. With what I want to fill it in, I'm going to use that. And this is an absolutely new function, completely different one. Now in here, I can actually, I'm going to borrow that code over there. And in here, instead of that, I'm going to do fill. So now this function, and that function are two different functions. Right? You're OK with that? All right. So now if I actually run this program, if I come over here, I can actually say line 40 characters with plus. So when the program is running, I'm pressing F10 to start, and I'm going to go F11 at the function to follow it. So when it comes over here, it says line with an integer. Where is it? It's here. So it jumps to that one. Executes that one. I'm going to go Shift F11 to completely run it and get out. Now it's actually executed and drew the line. Now when it comes to second one, it says I want a line with an integer and a character. So it goes to that one. And it prints that one. So the second one that is printed, it's with pluses. Are we OK with this? Now I can actually create something like this. Say, if yes. Because I didn't put using namespace std up there. If I say over here using namespace std, now there is no need for those. Remember that we talked about namespace. What did we say? Namespace is to prevent collision between names. Remember, we talked about abstraction? We talked about if I have a student in education and a student in OSAP department. The OSAP department's education, the OSAP department wants to have a student with specific information about the student that education doesn't care. They want to know how much money you loaned, how much money you owe them, what is your interest rate, and all those stuff. But a student in education department needs to know what is the GPA. So the abstraction, the idea of a student from an OSAP department and an EDU department are different, right? Now, if in Seneca I want to have the education student and OSAP student, how do I create two classes with the same name? I can't. Because of that, we create namespaces. We have an EDU namespace, they create a student in it. We have an OSAP namespace, they create a student in it. Now, if you are writing a main program, if you mostly are using education and not OSAP, you got to say using namespace EDU. And any student you create by default is from EDU. If you want to create a student for OSAP, then you have to say OSAP scope resolution student, which means now I don't want to do this. When they brought the idea of namespaces in C++, C++ actually didn't have that originally. When they brought the idea of namespace to C++, they said, okay, now that we have namespaces, where do we put all the default stuff that comes with the language? We're going to put it in a standard namespace. So all the code of the language of C++ is written in namespace std. Therefore, to access them, either you have to use namespace std or explicitly mention that I want std. Does that answer the question? All right. So yeah, so now I have the line like this. You okay? Now, let's say I want to get the line from the user. So I want to know what is the length of the line that I want to use. So if that's the case, I need to ask the user to tell me what is the size of the line, right? And that's a completely different function, but it still wants the line. So I can actually do like this. Now in here I can say cout, what is the length of the line? Or enter the length of the line. Enter, let me just, oh, people back there, can you see this or is it too small?
No, it's okay.
Huh? Can you see it?
It's okay.
It's okay? Okay. So I have to say over here, enter length of the line. Okay? Now that I do that, let me just bring that using namespace. Namespace std, I'm lazy. Okay. Actually, you know what? I'm going to do this. I'm going to come over here and I'm going to remove this too. Compile it and run it. Okay. Now this is the part that Git comes to play. So I'm going to come over here, not this Git, this one. Now in here I'm going to say commit. I'm going to say line without using namespace std. I'm going to commit and push. Okay. Now I'm going to say using namespace std. And I'm going to remove the stds from here. Okay? And it still runs perfectly, right? Now I'm going to do another commit. Now I'm going to say line with using namespace std, push and commit. Doing this, what you can do, you can simply go to the repository. In your repository, you can simply right-click and say, I want to see the logs. Now, in the logs, it tells you lines without, lines with. You see that? You double-click on it. It shows you the difference. So when you have using, you see STDs are removed. So it shows you what it was and what it is. Like this, you can actually see the differences in the code. It's very helpful. Okay? So back. Now let's go back and do this. So I'm going to bring that. Oh. And I'm going to write the code for this. So one more time. So in here, I'm going to say cout, enter the length of the line. Now in here, I'm going to have size t, length. And I can even do validation in here. I can actually say, hey, if it's between this and that, I'm going to default it. So I'm going to, it cannot be negative. So I'm going to say over here, cin len. So I'm receiving the length. Then I will say if length is equal to 0, then length is 10. So if somebody says 0, I'm going to put 10. If len is greater than 80, I have 80 in my line. It cannot be more than that. Greater or equal to 80, I'm going to say len is 79. So that's the only length that they can enter. And in here, I'm going to say return len. OK? So now I can actually write my code like this. I can write over here line. Now let's not make it too complicated. So in here, I'm going to say size t len is equal to line. Len over here, cout and again, I guess len is equal to line again. So now I can actually get two different lines. And it's going to ask me what is the length that you want to have. The length of the thing, I want 30. It's going to be 30. I want 50. It's going to be 50. So as you see, I have overloaded. This is called overloading, function overloading. I overloaded the line function in many different ways. That's polymorphism, doing the same thing in different ways. OK? So the line that doesn't have any argument receives the length of the line. The line that has an argument prints the line with a dash. The line that has an argument and a character prints a line with a character. Hence, polymorphism. We good? We good? OK? All right. The good way of writing this line thingy was like this. If I would write it, I would actually write it with a constant character pointer prompt. OK? And I would say over here, actually, let me show you something else. I'm going to change the sequence of the fill and the length. So I'm going to put it afterwards. I'm just redesigning stuff. Give me a second. Copy. I'm going to put it over here. And yeah. And then come back over here. In here, I'm going to let me run it, make sure it's good. 20, and 20. Okay, good. All right. Any problem with what I did? Are we good? Okay. Let's say I want to have another line written for this. And that line, I only mention the character. And if that's the case, I want 79 characters to get printed, a long thing, kind of a separator. And so if I create something like void line with character fill and nothing else, then I want this to happen. I want essentially, and I'm going to reuse that one. I'm going to say, I'm going to pass the fill over here, and I want 79 characters to get printed. You okay with this? So I can actually do like this. I can write separators now. I can say line to separate sections. So when I run this, one is character, the other one is integer. And if I write over here 30, it's going to draw a line for 79 characters. Now I'm going to write 50 over here, and it's going to do that. Are we okay with this? Any problem with this? Okay. So I'm going to take a snapshot of this at the moment. And say function overloading. So that's that. And in here, I'm going to call it A, overloading main. And in here, oh, not A. That's A, B, C, D. And here, I'm going to call it E, overloading lines. Now let's change these two. Now, there is a feature in C++ that is amazing with functions. That is this one. What is the difference between line 5 and 6? Only the second character, the second argument, right? Wouldn't it be nice if I could tell to the compiler, hey, if I didn't put the second one, put 79 instead of rewriting the code? Because that's essentially what it is. I'm literally calling the other function and putting a 79 over there, right? So my logic over here is that if I don't provide the second one, I want it to be 75, 79. You can do that. So instead of actually creating a new function, you can come to your lines and say, hey, remove this. And you remove the implementation for it. And you simply go to the prototype, say, if this wasn't available, put 79 instead. Done. This is called default argument value, which means now, without even writing line with no character, it will be done properly. Take a look. So when it's running, that we know what it does. It gets the thing. So I'm going to say over here 40, and it prints it and comes out. OK? So it prints 40 characters. Fine. But when it comes over here, it says, I want to call a line with a character. Do I have one? No. But I have another one with the default value of 79 for the second one. So I'm going to call this and pass 79 instead. So when you put a default value for the argument, when the function is called, it replaces it with the value. And now, if I actually go to the function, you will see that len is now 79 automatically. And fill still is the assignment thingy. And when it runs the same way. This is default value for arguments. If the logic of the overload that you are doing is identical to the old one, you're just calling it, just put default value for the arguments in the prototype. Remember, in the prototype only. So the compiler knows what to replace it with, and that is that. So, and that, ladies and gentlemen, is converting overload to default arg value when possible. Just remember that you can default it from right side only. You cannot have 3 arguments and put a default value for the middle one. That's not going to work, right? It has to be a proper function call. So you can start from right side. So if you have like 4 different ones, you can start from right side. And if you put 3 default arguments, then it can be called with 4, 3, 2, or 1. Okay? You can just pass it down. And that is that. So what you are going to do for the next day would be this. You're going to go through types overloading and references when you're coming for the lab. So I'm going to finish the whole thing over here and be done with it. And then you're going to get the workshop for it too. So the workshop for that will be due next week. So the workshop's going to come out today, and it's going to be due next week. So be aware of it. Next week, when I say next week, it's 10 days from now, something like that. Okay, so types and dynamic memory allocation is next week. So review your pointers. And I'm going to, and the day that so half of the day probably I'm going to talk about references. Overloading is done. Types is done. References is what's remaining. I'm going to go through that the next day. And you're going to have like a 15 minutes quiz. I'm just going to give you something to see what is your C knowledge. Okay? It's not going to affect anything in your, that means you got to pack up. Okay? So yeah, if you want to do a quick review of your C language before coming, I'll give you the questions the day before. So I'll tell you what the question is about. I'm going to tell you what is it about. I'm going to ask you to write a function to read values, pass it back by pointers, open a file, read comma-separated values from a file, something like that. But I'll give you the specific of the specific topics that you're going to be asked. Probably I'm going to give that today too. So you have time to review it, okay? Pardon me? Yeah, it's going to be an announcement on Blackboard. And it's not an announcement. I'll put the announcement on Teams, then I'll create an announcement on Blackboards with a link to Teams. I always do. Yes? Recording video is simply go to, there are 2, I'm going to upload everything to YouTube, so you're going to see a playlist coming up on YouTube. That's number 1. Number 2, if you click on the meeting, you are in the class list, right? Yes. So just open the meeting. You're going to see there's something that says recap. If you click on recap, video comes up to go through it. Okay, no problem. But again, it's not a guarantee. And all those people at home, come to class. Next time, I'm going to kick everybody out. Only me can stay in the thing. Unless you tell me I'm sick, I cannot come, I want to be online. If that's the case, if it is online, there's no guarantee you can be online. Other than that, next day, anybody who's online will get kicked out. Okay? It's for recording only. All right? This is not an online class. Have yourself a beautiful day, everyone, and I'll see you soon. Oh, it's from the lab. Oh, yeah. Workshops can only be submitted from the lab. Computer on the lab, physical computer on the lab, not your notebooks. No problem. Yeah. No problem. See you later. Hello, online people, can you hear me?
Yeah.
Perfect, thank you. All right. Oops.